we've just explored the two big ideas of the first half of calculus. We put them together, we said they're really the same idea. Now we begin to develop the notation that's going to help us do this better. Okay? This notion of plugging in numbers into a calculator and computing them is not what we're going to be doing. Okay? It's inefficient, it's not elegant, we don't learn anything by doing so. Okay? And it doesn't have good applications. So the next idea that we want to introduce, some of you have seen it before, okay? But just sort of like in math, we studied equations, we studied functions, we studied graphs. We're now going to introduce a new object called a limit. And we're going to start exploring that idea. Okay? So that's what we're going to introduce today. I am not giving you the actual definition yet. The actual definition is very complicated. We will build up to that. Okay? Instead, I'm going to give you a rough intuitive definition, sort of a middle step for what a limit is. Okay? So let f be defined on some open interval containing the number a. A is the point that we want to explore. So we've got a function that's defined around this particular x value, and we want to explore what's happening at that x value. Okay? We say that the limit as x approaches a of f of x is equal to L. So that's the new notation that we're introducing. This notation stands for the idea that I've written below. We're going to write this if, as x gets closer and closer to a, the f of x values get closer and closer to L. Okay? So again, this notation right here, this is the new notation that we're going to be using. Okay? This notation, another way to say this that might make a little more sense to you the first time you see it, is that as x gets closer and closer to a, we're saying that f of x gets closer and closer to L. Okay? Let's phrase that even another way. Okay? I'm saying that as my domain values approach a, my range values are approaching L. Okay? I would jot that down. As the domain values are approaching a, the range values are approaching L. That's the idea of a limit. Okay? When that happens, we will write this, but that means this idea. Okay? All right. Oh, by the way, let's practice reading this aloud. Okay? So this says the limit as x approaches a of f of x is L. All together, the limit as x approaches a of f of x is L. If tonight when you're working on your homework for this you say lim thingy, you're not ever going to learn it. You have to practice using the correct vocabulary as you work through these problems. Okay? All right. So let's look at an example here. You hopefully saw this graph momentarily in college algebra. Okay? The graph of this function, this is a complicated looking rational function. Okay? The graph of this rational function, let me get it right here, maybe something like this and this. This is the graph of this function right here. It's not a line, not quite. The graph of this function is a line with a hole in it. Okay? That hole is related to the fact that this function is not defined where? At 3. Can I just plug a 3 into this function to see what it spits out? No, why not? Let's say explicitly why we can't plug a 3 into this function. Because we'd have 3 minus 3 in the denominator, right? Which would simplify to a 0. And rule number 1 of math, right? Thou shalt not divide by 0, ever. Right? Rule number 1 of math. Cannot divide by 0. So 3 is not in the domain of this function. I would like to explore how this function behaves around 3. And so a limit is a tool for letting us do that. A limit allows us to, without actually plugging 3 into the function, explore what's happening around 3. Okay? So, let's do so. Part of what we're about to do should seem sneakily familiar. Okay? I'm going to go ahead and plug in not 3 into the function, because I can't. Let's plug 2 into the function. So if I plug 2 into this function, I get 2 squared plus 2 times 2. Not going to do it. Too close to the edge. If I plug 2 into this function, it gives me 2 squared plus 2 times 2 minus 15 all over 2 minus 3. If we clean that up, let's see, that's 4 plus 4 minus 15 is negative 7, thank you, all over negative 1. If I plug that in, I get 7. Okay, that should also make sense because that's what you see right here, right? F of 2 is 7. Okay. Let's plug in a point that's closer to 3 than that. Let's plug in 2.5. If I plug in that, it'll spit out a 7.5. If I plug in 2.9, it'll spit out a 7.9. And if I plug in 2.99, it will spit out a 7.99. Okay. So let me just show you what we were discovering here. I first plugged in a 2, and it spat out a 7. Do you see that? That's the order pair 2, 7 right there. The domain value was 2. The range value was 7. I then plugged in a number that was even closer to 3 than that. Like, I don't know, 2.9. And it spat out a 7.9. That's what we're doing here. Okay? Let's go from the other direction. Okay? So if I plug a 4 into this function, that'd be 4 squared, that's 16, right? Plus another 4, that's 20. Minus 15, that's 5. That doesn't seem right. 4, 16, that should be 8, right? So that should be 24 minus 15, which is 9. All over 4 minus 3. Anyway, it comes out to be 9. Okay. If I plugged in a 3.5, I'd get out an 8.5. If I plugged in 3.1, I'd get out an 8.1. And if I plugged in a 3.01, I'd get out 8.01. So again, what am I doing? I'm plugging in values around the interesting point that I want to explore, around the value A. Okay? And as I do so, it spits out numbers closer and closer to 8. Okay? So based on the graph above, which you can see from the graph or from the table, we could write this. The limit as x approaches 3. The domain value is approaching what? 3 in this table, right? In this table, we keep plugging in x values closer and closer to 3, right? Okay. The limit as x approaches 3 for this particular function appears to be what? 8. The range, as the x values get closer and closer to 3, the f of x values, the y values, appear to be getting closer and closer to 8. It turns out that that is the answer, by the way. I mean, you could say, well, maybe the answer's 7.9994, right? We don't know what the true answer is just by looking at this table. We don't know what the true answer is just by looking at this graph. Okay? I am still in this stage where we are developing an intuition. Folks, limits are not about doing what we just did, plugging in tiny numbers. Okay? Limits are not about that. But this is how you're getting an idea for what limits do. We're saying around 3, how is this function behaving? Around 3, the y values are getting close to 8. That is true. Okay? All right, so here it is. Oh, let's just say this. Notice to answer the question, we never had to find f of 3, which is good. Why? Because f of 3 is undefined. We couldn't do that. We never plugged a 3 into this function. Okay? That's a vital piece of working with limits. Okay? This is so important, folks. Okay? Calculus has to work this way. I have to show you I have to give you an idea of what a limit is before we actually start working with them. Okay? What we just did is an intuition. Okay? The above method is merely a guess. I cannot stress this enough. This above method is just a guess. Okay? This guessing method you will do in section 2.2, and that's it. And I will not have a question on your first exam where I ask you to guess the limit. Okay? Because I'm so opposed to that idea. I'll have you find the limit using properties. Okay? And in fact, let me show you how you will eventually answer this question for this problem. Okay? You won't understand all these steps. I'm perfectly fine with that. But I want to show you how we will actually show that the limit for this function is 8 going forward. Okay? So, folks, what do you do with a limit? You apply it to a function. Okay? The fancy word is that a limit is an operator on a function. Okay? So, it's like, what do you do with, if I asked you, what do you do with the square root? Nothing on its own. What do you do with a square root? You apply it to a number. Okay? What do you do with a limit? You apply it to a function. Sorry, that should be next. It has no meaning. You never will just see, just like you'll never see a square root sitting alone, you'll never see a limit sitting alone. It's something that you apply to something else. Okay? All right. So we're taking the limit as x approaches 3 of f of x. Well, let's actually get into the weeds. What is f of x? It was this function x squared plus 2x minus 15 all over x minus 3. Okay. What I'm going to do now, and this is typical of how you'll work with limits, is I'm going to start working inside the limit. Okay? Most people will not write parentheses here. There's no need to, because we all understand that they're there. But maybe you should practice putting parentheses around your limit until you get comfortable with it. Okay? So working inside the limit, not applying the limit, not taking the limit, just working inside of it, I'm going to factor my numerator. This numerator factors to be x minus 5 times x plus 3. Oops, that's a lie. This factors to be x plus 5 times x minus 3 all over x minus 3, and you can check that. Okay. Further working inside this limit, we notice that these two factors can reduce out. That's nice. Sometimes that'll happen. Okay. I think you should have followed all the steps I just did, because all I was doing there was algebra. Okay? This next step is not clear. What I'm about to do, it's not clear that you should be allowed to do what I'm about to do. Okay? It's called the direct substitution property, and we will specify later on when are you actually allowed to do this move. In this case, we are allowed, oops, shucks. Shucks. Folks, all of these should have a what? I was putting a, and I should be putting what? The limiting value of 3 for each of those. Yar, 24. Okay. Please. Be generous. Okay. This next step is called the substitution property. Okay. I can only do it because this is a nice, well-behaved function, whereas what we started with wasn't. I've reduced this down to a point where it's well-behaved enough to apply the substitution property, so I can go ahead and in place of x, put a 3, which is where we get that limit. Notice from this step to this step, I applied something, and the limit is no longer there because I'm applying the direct substitution property. Okay. This is the actual work that we got a guess at while we were doing this plug and chug. Okay? All right. It's the end of the first week. We're only about a week and a half behind, so we're doing good. Okay. Please, please, please get into my math lab. Start working on it. Folks, I don't send out reminders to you saying do your homework. Okay, I just assume that you're working on it. Okay. Do go ahead and I would recommend just printing out all the rest of the notes for this unit. Okay. Let's see. I do want to speak with Maggie if she's here. Great, we'll talk. If you weren't here the first day, also if you'd come see me. Okay. And that's all I've got. So if you would just leave your cards on the desk, I'll pick them up. Sir, what's your name? Okay, Brendan. I have two things for you. Would you email me so I can give you one of these questionnaires? Have you fill it out? Okay, if you would email me, I'll send that to you. If you would right now, give me a note card. Put your first name, first and last on there. Please give me your preferred name, whatever you want me to call you by, because that's what I'll be looking at this to know what to call you. Okay? Your major or interest. And that's good enough.
Questionnaires?
Thank you. Yeah.
Brett?
Yes, thank you. Yeah. Did you get a card?
No, not today.
Okay, so the card's how I'm going to know whether you're here. So you want to even if you're late, at the end of class, come pick it up.
Okay.
I'm not seeing your card. Did you get one last time?
Oh, yeah.
What did you say your name was?
It's right there.
Oh, Kaya. Okay, you said Brett. I'm sorry.
Not at all.
Thank you.
Thank you.
Okay, so just set that on your desk.
Oh, perfect.
Yeah, and if you would just set that where you're sitting, so I can pick it up. It seems silly, but whatever's left in my hand, I'm going to count as absent. Michael.
So as far as like what I missed this morning, this quiz,
Yes.
got like all the other units and stuff.
Good.
I did
Okay.
some kid power sliding in my truck when I was
Oh.
trying to like.
I'm sorry to hear that. Okay, yeah, yeah. Well, thanks for letting me know. I appreciate you telling me. Yeah. Remind me your name?
See you guys.
There you are. Great, thank you. If you would just set that at your seat. Yes. So that's all I need from you, because I did show you in class today how to get into my math lab. Okay, so make sure you do that. You'll need to either get a temporary access code, have purchased one, or purchase one through the publisher when you go into that. If you're not sure what to do, just go ahead and get the temporary one. It's good for 14 days. Okay. So you can get started on the homework. Our first assignment is due Monday evening, and so you'll want to be working on that. Okay. The notes are always posted under D2L and content. I recommend just going ahead and printing them off because I won't bring copies. Okay, great. Remind me your name again?
Brendan.
Brendan, great. Thanks. Welcome. Yeah. Take care. Yes.
Sorry, I wasn't. I don't have a copy of these, but I'll read them today.
Okay, great. Great. And it's Will Garcia, right? Yes. Yes. Okay. So if you would just set that at your desk, just so, because I've got now 4 people that work here. Well, I think she was here. Summer here?
Yeah.
Summer. Oh, okay. There. Cool. Was that? Did I get your?
Yeah. Liquor.
Oh, thank you.
Yeah, there.
I hope they're helpful. Oh, speaking of, let's stop this.